Welcome to Mathematics with Tom. I am Tom. And today we're going to look at the graph of r times cosine of omega t minus alpha. And I thought what we would do is, instead of just giving it to you in one lump sum, is that I'm going to try to build my case for the intuition of it. So here we go. We're going to start, and we're going to build our case. We're going to start with just the graph y of t equals cosine of t. That's our most simple case. So I'm going to graph this, and we're going to be adding on quite a bit to our graph. So give yourself some space. And okay. So I'm going to graph this. Here's pi over 2. So pi over 2. I'm going to go to 2 more units over. I'll put, this would be pi. I'm going to go 2 more units. This is 3 pi over 2. And finally, the last one will stop at 2 pi. It's 2 pi because that's one full period of cosine. We'll talk about period here in a moment too. So our horizontal axis is t, our vertical axis is y of t. So this all assumes that you're comfortable with the base picture of the cosine of t. So the cosine of t, it starts up here at 1, has a lowest point down here of -1, and it goes down to pi over 2, it's at 0. At pi, it's at -1. 3 pi over 2, it's back up to 0. 2 pi, it returns to 1, right where it started, and after that it continues forever. So I'm going to sketch this in this color. So it comes down, goes through my little pi over 2 there, rounds out, comes back up through 3 pi over 2, and ends as it might be a little too roundy there, so let's come up maybe like that. There, that's a good looking cosine curve. Kind of a little off in the middle there. I'll smooth that out. But that is cosine of t. So this is y of t. I'm going to call it y1. We'll keep track. y1 of t. Now, let's grab another color, like maybe this pretty green, and we're going to graph y2 of t. And let's do this. Let's make this cosine. And I probably won't be writing the parentheses much after that, but so cosine parentheses 2t, or we could loosely write it as cosine of 2t. It's pretty obvious what it is. Well, think about what happens. So let's just try a few values. Where is cosine? So where is y2 of pi over 2? Well, this becomes the cosine of 2 times pi over 2. Well, that's the cosine of pi. Well, the cosine of pi, oh my, the cosine of pi is all the way down here at -1. But now it's happening at pi, at pi over 2. So at pi over 2, I'm already at -1. Okay, and then, well, let's try pi. What happens at pi? So y2 of pi, this is the cosine of 2 times pi. Well, we know that. We can look at y1 of t because there it's back to 1. In other words, wow, this function has taken and it is cut. It's gone through its full period in half of the time. So let's do this. So at pi over 4, that's really going to be the same as pi over 2. So let's graph this. So this is y2 of t. It starts at 1. It starts at 1, and it comes down to 0 at pi over 4. Comes down to -1 by the time it gets to pi over 2. Then it comes back up at 3/4 of pi, and it's at 0. And by the time it gets to pi, it's back up to 1. So let's do y2, notice this, y2 of t completes one cycle or period, and we're going to call it t, period t, in pi time. And then, remember what else we said? We said that y1 of t completes, oops, it should have been 1 period t equal 2 pi. Well, what is the relationship between these? The relationship is whatever omega is. And this is how we find it. So the period t is equal to 2 pi divided by whatever omega is. So as omega gets larger, cosine goes through its cycle faster. As omega gets smaller, like if that omega was 1/2, then it would take 4 pi to go through one cycle of cosine. So that is our period. So t is a period. Now the other question though is how fast, where is cosine after 1 unit of time? Well, 1 unit of time, well, remember pi over 2 is about 1.5. So pi over 4 would be about 0.75. So pi over, so somewhere right about here would be the actual number of 1. So in other words, how much has cosine gone through its period at time equals 1? And how much has cosine of 2t, how much of its period has it gone through? Well, that is called frequency. So frequency, we use an F for frequency. So don't get it confused with like F of something. But so the frequency is the amount of the period of cosine, and it works for sine and tangent, cosine completed in 1 unit of time. And the other aspect of that is, so we get the frequency, but frequency is just how much have we completed of the whole. So frequency is just how much one piece of the whole. Well, the whole thing is 2 times pi over omega. That's the whole period. So we just want a fraction, 1 fraction of that. So you can simplify that frequency is the same as omega over 2 pi. Okay, we're down to the last piece, our last piece here. What about this? What about if we have y3? So I probably need another color. How about this? I'll use this red, it's very pretty. So y3 of t is going to be, y3 of t is going to be, well, let me see. Yeah, we'll try it. We'll try it this way. The cosine. So now, really, what I'm doing is I'm modifying y1. The cosine of t minus pi over 2. T minus pi over 2. Well, what that does is it takes t1, because really what this is equal to y1 of t minus pi over 2. Well, that just creates a shift. That just creates a shift to the right. So in other words, if my cosine, and let's do that, we have this red, my cosine originally started at 0, now it would start up here at pi over 2 and then complete it. So it would complete its cycle starting here at pi over 2, come down to pi, then it would be down at -1 at 3 pi over 2, and then it would continue on. It'd be back up at 0 at 2 pi, and then at another 2 pi plus pi over 2, it would be coming to an end. Okay. Now let's go back. If I went backwards, where is this function? Oh, look at that. It lands right back at 0. Well, let's just do a quick check. Is y3 of 0, 0? Oops. So let's do this. So let's check. y3 of 0, this equals the cosine of 0 minus pi over 2. Well, that's the cosine. That's the same as the cosine of pi over 2 because cosine's even. Well, that's 0, so that checked out. Okay, now for the hard one. And this one we definitely need another color. We'll try this pink color here. It's similar to the red, or the first one. Let's see, is that different enough? It's getting close here. Maybe this one's better. Yeah, here's a new color. Yellow, soft yellow. So here we go. y4 of t. Well, what we're going to do now is we're going to look at cosine of 2t minus pi over 2. Okay. Well, remember, let me go back with my colors. y4 is 2t. So I'm just going to green it back up again. Well, what you have to be careful of here is you have to think about how the shift works. And the shift would work by what you could substitute it into. And in order to make this work, what you need to do is you need to write this as the cosine of 2, then you factor a 2 out. So this becomes t minus pi over 4. That's the actual shift that we're looking at. So if we look at our green graph, that was what we were working on. This green graph is now shifted. It shifted everything about it. And actually, I'm going to extend my green graph because remember at pi over 4, it's already back down to 0. And then it continues back down to -1 by negative pi over 2. So what happens? What happens then is y4, it shifts. Everything gets shifted by pi over 4. So this point moves to there. This next point would move here. This next point would move to right here, and so on. And that would be my new y4. So this is getting pretty colorful in here. But it would start at 0. It would go up to 1. Then it would come back down to 0 at pi over 2. Come down to 1. Back up to pi. And then back up to 1. So notice this. It actually, here is the complete cycle from pi over 4. From pi over 4 to that looks like 5/4 of pi. Well, the other thing though is let's check. Notice according to our graph, it starts at 0. Let's just make sure that works. y4 of 0. Let's see if it matches our graph. This is the cosine of 2 times 0, that's 0, minus pi over 2. Oh, and we already discovered that that is in fact 0. Okay, there's one last piece, and that is r. How does r change things? Well, all r does is it either stretches or compresses the height of the function. So r just changes the multiplier of 1. So I'm going to now go to my next page and let's actually graph this whole, put this all together in the general perspective. Let me find a clear page here. There we go. Okay, so if we have the graph, we'll call this one y. Just this is our in general. Y of t is r times the cosine of omega t minus alpha. Okay, then here's what we get. Here's what we get. Let's make a nice graph of this over here. We'll do a little work on the side there. Now I know this looks like I'm starting the picture the same, but remember this has changed now. One complete period ends right here at capital T. It's not 2 pi anymore. What did we say it was? We said it's 2 pi over omega. So if I was to graph this, this first point is no longer pi over 2, it's pi over 2 divided by omega. And their next point is no longer pi, it's pi divided by omega, and so on. So 3 pi over 2 divided by omega. Now the next piece then is we have a shift, and how do we determine our shift? So our shift is r cosine of omega, then we factor that out. So this becomes t minus alpha over omega. Well, so it starts at some point alpha over omega. So what we've done is maybe it starts, I'm just going to use this because it's easy here. I'll pick an undeterminate point. So how about right here? So this, we'll do this in blue. So this would be its starting point. That's hard to see that it's blue. This right here is my starting point of alpha over omega. And this curve now has a height. It has a height of r down to minus r. So it would start right there, and then it's going to be shifted by this pi over omega each time. So let's put in our shifts here, kind of about like that. So there's my ending point. There's my negative point. And now my new curve looks like this. That is the new picture. That is the new picture of, or the general picture of y of t equals r cosine omega t minus alpha. I hope that helps. Thanks for watching.